Hi everyone, this is the second video for section 7.4 on percents. So in this video, we're going to start talking about percent increase and decrease problems. So these aren't covered, I don't believe, in the book, but they're what people really use percents for just in everyday language. So I think it's important to cover them. So these problems are going to have the general form where a part equals the whole plus some percent of the whole. And so this is going to be what's different between a basic percent problem and a basic percent problem and the percent increase decrease problems. So to really explain what this means, I think it's easiest to just go straight into our first example, just so I can kind of show you what's going on. One thing to note for really the rest of the worksheet is that we're going to round to the nearest whole number. So we're going to round to the nearest whole number. Okay, so that's what's going to happen. So between, like I said, I think it's easy to just go into this first example. So between 1990 and 2005, so we have these 2 years, the price of an average house in a town increased from 44,000 to 97,000. So I guess we're just underlining important information here. The percent increase decrease problems will always have some word that tells you if it's an increase or a decrease. So in this problem, it was a little bit more clear because we just had the word increase. And so increase means, well, you're increasing and you're getting more. So there's some addition in price. And you can see that based on the numbers. We're increasing and adding from 44,000 to 97,000. So that's what's going to tell us that we're going to use a plus in this equation. So this plus minus in the part equals the whole plus or minus the percent of the whole. That plus minus means that it's either going to be a plus for an increase problem or a minus for a decrease problem. So there's always going to be a word in the problem that tells you which one it is. Okay, so we're increasing from 44,000 to 97,000. So in these, we're going to have a percent increase or decrease. We're going to have an increase or a decrease, and then we're going to have a part and a whole. So our whole is always going to be our starting value. So the value 44,000 corresponds with the year 1990, and our part is always going to be more so like the current value. So what it is later in time or currently. And if that's going to vary problem to problem. So even though it's not currently 2005, 2005 is the later date. So that's what's going to be represented by this part. So the whole is the initial value and the part is really like the ending value. And a lot of these problems are also going to have to do with money. That is something to note. Because if you think about how we talk about percents, people often talk about increasing the price increase this much or decrease this much. And we like to analyze prices. Okay, so now that we have our part, our whole, and our increasing, we want to set up our equation. So using the formula that's at the top of the page, we have that the part 97,000 equals our whole 44,000 plus a percent of the whole. So this problem, we're not given a percent. So you're only going to be given 3 of these 4 things. Out of the part, the whole, the percent, and the increase decrease, you're only going to be given 3. We solve for the 4th one. So we're looking for some percent of 44,000. And so then all you have to do is just solve for P like we would normally do in our college algebra class. So we can subtract 44,000 from both sides. And we can see that we should get 53,000 over here. So 53,000 equals P times 44,000. And then we just divide. So 53,000 divided by 44,000 equals P. And if we just want to simplify that, we can take the thousands off. So this is 53 over 44. So I know that 44 is 4 times 11. I don't know if 53 is divisible by anything. So we can think through our divisibility rules. It's not divisible by 2. 5 plus 3 is 8, so it's not divisible by 3. I don't think it's divisible by 4. What's divisible? 48 is divisible by 4, so then 52 is divisible by 4, and this one's not. It doesn't end in a 5 or a 0. It's not divisible by 7, because 7 goes from 49 to 56. It's not divisible by 8, because it's not divisible by 4, or 2 for that matter. 5 plus 3 is 8, so it's not divisible by 9. It's not divisible by 3 or 4. Yeah, I'm pretty sure that 53 is prime. So remember, based on our test for prime numbers, this square root is going to be between 7 and 8, so we would only have to test the primes up to 7. So it's not going to, 53 is going to be prime, so we can't simplify this anymore. But I don't see a clear way in which to get this as a fraction over 100. Remember that our percents are fractions over 100, or fractions with a denominator of 100. So I'm just going to divide this into a decimal because I don't see a better way to write it as a decimal or percent or anything of that nature. Okay, so we're doing 53 divided by 44. So 44 goes into 53 one time with 9 left over. We're going to add, well, this one doesn't need to be here. So this goes in 9 times, and then we're going to add a 0, bring it down. So 44 goes into 92 times, because 45 times 2 is 90. So then this is going to be 88 with 2 left. We can bring a 0 down. 44 doesn't go into 20. So we can bring another 0 down. 44 goes into 200. Probably less than 5 times, because 40 times 5 is 200. So let's try 4. 44 times 4 is going to be 160 plus 16, which is 176. Subtract that, we get 14. And this will keep going. So 1, I don't have room on this paper because I didn't give myself enough room. But also, you can see that this is approximately equal to 1.204. So the only reason that I am rounding this right here is because of what I wrote here at the top of the page. We're going to round to the nearest whole number. So because we know that to convert a decimal to a percent, we're just going to move the decimal place twice. This is all the digits I need, because this tells us that the percent here is 120% if we move that decimal twice and then round to the nearest whole number. So the percent, so then we just write this percent as an actual percent. So if you're given a percent problem, although we know that we can write percents as fractions and decimals, you need to write a percent for your answer. So the percent increase is 120%. Okay, so that's how you do problems like this. So let's talk about what this means more so. Because a lot of people don't know what we mean when we talk about percent increases and decreases. So one thing that I want to note is that a 100% increase corresponds to doubling. So if the price exactly doubles, we are going to call that a 100% increase. So 100% increase corresponds to doubling. So in this example, the percent increase was 120%. And you can see that that's consistent with this because the price more than doubled. right? If the price doubled, then we would have gone from 44,000 to 88,000. But we went more than that. We went all the way up to 97,000. So it more than doubled. And so that's why the percent increase is above 100. A lot of people misinterpret this and think it's only increasing by 20%. So only increasing by around 9,000, but it increased by 97,000. So that's a really big difference. So just make sure that you know this is something that may not be obvious whenever you're just given these equations. So make sure that you know what it means so that you know how to talk about it. Okay, so let's do the next example. So we have a store that reduced the price of a computer 20% and sold it for $1,680, so $1,680. And we want to know the original price of the computer. So remember that we're looking for four things. We're looking for our part, our whole, our percent, and then an increase or decrease word. So our increase decrease word in this is reduced. So this is going to be reducing corresponds with subtracting. So we reduce the price by 20%. So that's going to be our, well, I'll just go ahead and put percent here. And remember that when we did this first one, our whole was always our starting value and our part was always our ending value or current value, however you want to think of it. So the original is going to be the whole, and the new price is going to be the part. So now we can set up our equation. So our part, which is 1,680, equals our whole. So I'm just going to put in a W here to represent whole. And then we have a subtraction sign because we're reducing the price. And then we have our percent, which is 0.2 when we convert it to decimals. And that's again multiplied by our whole. So our percent of our whole, remember of has an implied multiplication. So this is the equation that we're going to solve. And whenever you look at this, it makes sense how the percent, where this percent increase decrease formula comes from. Because, well, you see, we start with our initial price, right, our whole, and then we subtract 20% of the whole. And that's why we talk about it as a 20% decrease. So the way you would talk about this is the percent decrease is 20% because we took our initial value and decreased it by 20% of that initial value. And we ended up here with 1,680. So whenever you look at the equation, it makes sense why it's set up this way. Okay, so now we want to solve this equation. So because we have the variable w 2 times, we want to consolidate that and only have the variable w once. So we can do this by either reverse distribution or factoring things out. We can see we have two w's here, so we can factor this as w times 1 minus 0.2. So this is called both things, reverse distribution or just factoring out the x. Okay, so we can factor that out. And then we can actually perform that operation. So 1 minus 0.02 is 0.8. And then we can divide. So 1680 divided by 0.8 is our whole. So remember that whenever we are dividing decimals, we just change the problem so that we're really dividing whole numbers. So instead of having 1680 here, I'm going to multiply it by 10. And then instead of dividing by 0.8, I'm going to divide by 8. Right, remember that whenever we have a division with decimals, we just make it a division with whole numbers. Okay, so we are doing this division. So 8 goes into 16 2 times. With 0 left over, we bring down the 8. 8 goes into 8 one time. With 0 left over. And because we're just going to carry down zeros, we just fill in zeros here. This is going to be 2,100. So that's all we had to do to solve this problem. So that tells us the original price was $1,200. Okay. Oh, sorry, not $1,200. $2,100. Okay, and that's all you have to do. So although these may look kind of long problems at first, you really just have an extra step because you have to deal with some adding and subtracting there, either combining it by factoring out a variable or doing the step of subtraction or addition. But this is just our kind of examples, our standard examples for percent increase and decrease. So the next example, example 5, combines a lot of the concepts that we've gone through kind of overall this semester. So I'm going to, it's a really long example with multiple parts, so I'm just going to wait and start that in the next video.